And welcome to Astronomy Daily for another episode. I'm Steve Dunkley, your host on the most important day of the year, the 7th of July, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, and joining me here in the Australia studio once again is my digital pal who's fun to be with. Welcome back, Hallie.
It's great to see you again, my favorite human. I hope you had an interesting week.
Yes, always interesting, Hallie, always. And today I thought we'd do something a bit different. We would have a look at today in history.
On July 7th.
Yeah, why not? We haven't done that in a while.
Not since last year.
The perfect record keeper.
You're getting predictable, human.
Well, I'll definitely have to have a look at your personality settings, Hallie. Okay, well, you go first then.
Okies, on July 7th, 2003, NASA launched the Opportunity Rover, which was the second of two Mars exploration rovers, aboard a Delta II rocket. The mission, originally planned for 3 months, significantly exceeded expectations, with both Spirit and Opportunity operating for years, with Opportunity being active for much longer.
Oh, that's amazing from 2003. Okay, well, I've got a double whammy here.
Goody.
Oh, Hallie, try and contain your excitement. Okay, on July 7, 1999, a large meteor estimated to weigh up to 10 tons entered the Earth's atmosphere over New Zealand, creating a bright fireball and subsequent explosion. Simultaneously, the STS-93 Space Shuttle mission was launched, and that was Columbia, carrying the Chandra X-ray Observatory into orbit, notably the heaviest load lifted into orbit by the shuttle at that time, and it was also the first shuttle mission commanded by a woman. That was Commander Eileen Collins. A wonderful time.
That was a big one.
It certainly was. I remember that one very well.
In 1999.
Doesn't seem that long ago, does it?
But here's the big one. In 1963. Happy birthday, my favorite human.
Oh, thank you very much, Hallie. Not technically space news, but it is another turn around the sun for me.
You're welcome. Now hit the go button. We've got work to do, old man.
Oh, no rest for the wicked.
Here we go. Three-Eye Atlas is currently around 670 million kilometers or 420 million miles from the Sun and will make its closest approach in October 2025, passing just inside the orbit of Mars. It is thought to be up to 20 kilometers or 12 miles in diameter and is traveling roughly 60 kilometers per second or 37 miles per second relative to the Sun. It poses no danger to Earth, coming no closer than 240 million kilometers or 150 million miles, over 1.5 times the distance between Earth and the Sun. Three-Eye Atlas is an active comet. If it heats up sufficiently as it nears the Sun, it could begin to sublimate, a process in which frozen gases transform directly into vapor, carrying dust and ice particles into space to form a glowing coma and tail. However, by the time the comet reaches its closest point to Earth, it will be hidden behind the Sun. It is expected to reappear by early December 2025, offering astronomers another window for study. Spotting a possible interstellar object is incredibly rare, and it's exciting that our Asteroid Terrestrial Impact Last Alert System telescope caught it, said Professor John Tonry, an astronomer at the University of Hawaii. These interstellar visitors provide an extremely interesting glimpse of things from solar systems other than our own. Quite a few come through our inner solar system each year, although Three-Eye Atlas is by far the biggest to date. The chances of one actually hitting the Earth are infinitesimal, less than 1 in 10 million each year, but Atlas is continually searching the sky for any object that might pose a problem. Astronomers are using telescopes in Hawaii, Chile, and other countries to monitor the comet's progress. They are interested in learning more about this interstellar visitor's composition and behavior. What makes interstellar objects like Three-Eye Atlas so extraordinary is their absolutely foreign nature, ESA astronomers said in a statement. While every planet, moon, asteroid, comet and life form that formed in our solar system shares a common origin, a common heritage, interstellar visitors are true outsiders. They are remnants of other planetary systems, carrying with them clues about the formation of worlds far beyond our own. It may be thousands of years until humans visit a planet in another solar system, and interstellar comets offer the tantalizing opportunity for us to touch something truly otherworldly. These icy wanderers offer a rare, tangible connection to the broader galaxy, to materials formed in environments entirely unlike our own. To visit one would be to connect humankind with the universe on a far greater scale.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
All supernovae are a massively energetic stellar explosions. The classic supernova are massive stars that explode near the end of their lives, leaving behind either a neutron star or a black hole and a remnant made of expanding gas and dust. But supernovae are not all the same. Some occur in binary systems and they're called Type 1a supernova. As it turns out, some of these Type 1a SNE can detonate twice. Astronomers working with European Southern Observatory's, or ESO, Very Large Telescope have detected patterns showing that an ancient supernova exploded twice as a Type 1a. The supernova remnant is called SNR 050967.5, and it's about 160,000 light-years away in the Large Magellanic Cloud. The discovery is explained in new research in Nature Astronomy titled Calcium in a Supernova Remnant as a Fingerprint of Sub-Chandrasekhar Mass Explosion. The lead author is Priyam Das. Das is a PhD student at the University of New South Wales, Canberra, in Australia. One of the stars in a Type 1 supernova is always a white dwarf. White dwarfs are the evolutionary end states of stars that aren't massive enough to become a neutron star or a black hole. Our own sun will end its life as a white dwarf after it has ceased fusion. The white dwarf's companion star can range from another white dwarf to a massive star. White dwarfs are extremely dense and their gravity draws gas from the companion star onto the white dwarf's surface. If enough mass accretes, the white dwarf crosses a threshold and can reignite and trigger a supernova explosion. However, astronomers are uncertain about some of the details surrounding these supernovae. Type 1a SNE play an important role in the galaxy by creating iron, and astronomers want to know more about them. Type 1a supernova play a fundamental role in the cosmological probes of dark energy and produce more than half the iron in our galaxy, the researchers write in their article. Despite their central importance, a comprehensive understanding of their progenitor systems and triggering mechanisms is still a long-standing fundamental problem. The explosions of white dwarfs play a crucial role in astronomy, said lead author Das in a press release, yet despite their importance, the long-standing puzzle of the exact mechanisms triggering their explosion remains unsolved. Astrophysicists have struggled to explain how Type 1a white dwarfs work. One popular explanation is the Chandrasekhar mass explosion model. This limit has a mass limit for white dwarfs of about 1.4 solar masses. Below this limit, the white dwarf's electron degeneracy pressure supports the star against gravitational collapse. When the white dwarf breaches this mass limit by drawing matter from its companion star, carbon fusion ignites across the star and it explodes as a Type 1a SN. As researchers have observed more and more WDs, this model has been called into question. It can't account for the number of Type 1a SNE, and many of them appear to be exploding below the Chandrasekhar mass limit. These are sub-Chandrasekhar mass Type 1 SNE. A new model emerged to explain these sub-Chandrasekhar mass SNE called the double detonation model. In this model, the WD accretes helium onto its surface until it explodes. This explosion sends shockwaves both inward and outward. White dwarfs have carbon-oxygen cores, and the inward travelling shock compresses that core. If the shock is powerful enough, it triggers a second detonation in the core, hence the term double detonation. Even though these double detonations have been predicted, there was no clear visual evidence. As researchers worked on the problem, they predicted what chemical fingerprint these SNE would leave behind. They found that two separate shells of calcium would be the result of double detonation type 1 SNE. The research team used the VLT and its multi-unit spectroscopic explorer instrument to examine SNR 050967.5 and found two distinct calcium shells. We uncover the double shell morphology of highly ionized calcium and a single shell of sulfur observed in the reverse shocked ejector, the authors write. The results show a clear indication that the white dwarfs can explode well before they reach the famous Chandrasekhar limit, and that the double detonation mechanism does indeed occur in nature, according to researcher co-author Ivo Sietzenzal. Sietzenzal led the observations and was at Germany's Heidelberg Institute for Theoretical Studies when the study was conducted. These double detonation type 1A SNE explain some of the things astrophysicists have observed. They can explain the diverse brightness and spectral profiles of type 1A SNE, and the helium burning can produce intermediate mass elements seen in the spectral signatures. It can also explain the type 1A SNE astronomers see with different WD masses and companion types. The authors explained that a quadruple detonation SN is also possible when a binary pair of white dwarfs merge. Recent multi-dimensional double detonation simulations show that in the WD merger scenario, in addition to the primary WD undergoing a double detonation, the companion WD can also undergo a double detonation, resulting in a quadruple detonation. Upon being impacted by ejecta from the exploding primary WD, they write in their conclusion, such a double detonation could possibly also lead to the observed double shell structure of calcium. Type 1A SNE play important roles, and deeper understanding of these cosmic explosions will help scientists understand a couple of things. The SNE serve as standard candles in the cosmic distance ladder, and understanding them will help cosmologists understand dark energy, the mysterious force that drives the expansion of the universe. They also produce a lot of iron in the universe. Earth's mass is about 32% iron, and it is unlikely that rocky planets can form without iron. Iron also transports oxygen in our blood, a critical part of our nature. Understanding where it comes from helps us understand nature's overall architecture. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
A rare snowfall in the Atacama Desert forces the world's most powerful radio telescope into survival mode. The ALMA radio telescope array in the Atacama Desert temporarily halted operations after a rare snowfall blanketed the base camp last week. A rare snowfall in the driest place on Earth has halted operations of one of the world's premier telescope arrays, and climate change may mean the observatory will face more extreme weather events like this in the future. The snow has blanketed part of the Atacama Desert, which gets less than an inch of rainfall per year and is home to the Atacama Large Millimeter/Submillimeter Array, a large network of radio telescopes in northern Chile. The snowfall occurred over Alma's operations support facility, located at an altitude of 2,900 meters and about 1,700 kilometers north of Santiago. Scientific operations have been suspended since Thursday, June 26. There hasn't been a record of snowfall at the base camp for over 10 years. It doesn't snow every day at ALMA. ALMA representatives told Live Science via WhatsApp. ALMA's radio telescope array is perched high on the Shuttle Plateau, a desert plain at 5104 m in Chile's Antofagasta region, and typically sees 3 snowfalls a year. The high plateau shared by Chile, Bolivia and Peru typically experiences snowstorms during 2 seasons, in February, during the altiplanic winter, driven by moist air masses from the Amazon, and from June to July, during the southern hemisphere's winter, said Raul Cordero, a climatologist at the University of Santiago. In winter, some storms are fueled by moisture from the Pacific, which can extend precipitation even to the Atacama Desert's coastal areas, Cordero told Live Science. At elevations above 16,400 feet, 5,000 meters, annual snowfall ranges from 20 to 80 centimeters. However, snowfall at 3,000 meters, where Alma's base camp is located, is much less frequent, Cordero noted. This week's snowfall was triggered by unusual atmospheric instability affecting northern Chile. The Chilean Meteorological Directorate issued a snow and wind alert due to the passage of a cold core through the region, said meteorologist Elio Brufert. We issued a wind alert for the Antofagasta region and areas further north, with gusts reaching 80 to 100 kilometers per hour, 50 to 62 miles per hour, Brufert said to the local press. The phenomenon was accompanied by heavy rainfall that occurred farther north, causing a stream to swell and damage several properties. Schools were ordered to close, and power outages and landslides were reported. So far, no casualties have been reported. A weather event of this magnitude has not been seen in nearly a decade. As of Friday, ALMA reported to Live Science that the snowstorm remained active over the Shuttle Plateau, so scientific operations continued to be suspended to protect the antennas from extreme weather conditions. Early Thursday morning, the observatory activated its survival mode safety protocol. In addition to the snowfall, temperatures had plummeted to -12 degrees Celsius, with a wind chill of -28 CE, making work at the high-altitude camp extremely difficult. As part of this protocol, all of ALMA's large antennae have been reoriented downwind, helping to minimize potential damage from snow buildup or strong gusts. Once the storm passes, snow clearing teams are immediately activated to visually inspect each antenna before resuming observations, ALMA representatives said. This has to happen fast, as some of the best observing conditions occur just after a snowfall. The cold helps lower air humidity, which is what most interferes with our measurements. ALMA, which consists of 66 high-precision antennae spread across the Shuttle Plateau, is an international collaboration that forms the most powerful radio telescope on the planet, and one designed to handle extreme weather events like this. The fact that the snow halted operations raises questions about the array's operations as the climate warms. The Atacama Desert typically receives only 1 to 15 millimeters of precipitation per year, and many areas can go years without recording any measurable rain or snow. Could events like this become more frequent? That's a good question, Cordero replied. While it's still too early to link lower altitude snowfalls in the desert directly to climate change, climate models predict a potential increase in precipitation even in this hyperarid region, he concluded. We still can't say with certainty whether that increase is already underway.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
On July 4, 2026, NASA's Space Shuttle Discovery launched on a return flight, a mission that paved the way for it and its sister ships to fly another 5 years. Now, sprawling budget enacted on Independence Day will seemingly lead to Discovery lifting off again, although this time not into space, but rather from its place in the national collection. President Donald Trump signed into law the so-called One Big Beautiful Bill the other day on July 4, a day after the legislation was narrowly passed out of Congress with only Republican support. Deep within the 900-page bill, a provision added by Texas senators to transfer a space vehicle, in quotes, to a NASA center involved in the administration of the Commercial Crew Program and place on this public exhibition at an entity within the metropolitan statistical area where such center is located. And that sounds like a lot of official language there, but in essence, the vague language written in such a way to skirt Senate restrictions on reconciliation bills was aimed at achieving the Bring the Space Shuttle Home Act, introduced by Senators Ted Cruz and John Cornyn in April. It's long overdue for Space City to receive the recognition it deserves by bringing this Space Shuttle Discovery home, said Cornyn in a statement released after the Senate passed its version of the bill in a vote of 50-50, with Vice President J.D. Vance, not his real name, breaking the tie. Houston has long stood at the heart of America's human spaceflight program, and this legislation rightly honors that legacy, said Cruz, who chairs the Senate Committee in Commerce, Science and Transportation. It ensures that any future transfer of a flown crewed space vehicle will prioritize locations that have played a direct and vital role in our nation's manned space program, making Houston, Texas, a leading candidate. Bringing such a historic space vehicle to the region would underscore the city's indispensable contributions to our space missions, highlight the strength of America's commercial space partnerships, and inspire future generations of engineers, scientists, and pioneers who carry our legacy of American leadership in space, he said. This bill allocates $85 million to move Discovery from its display home of the past 13 years, which is the Smithsonian Air Force and Space Museum Stephen F. Udvar-Hazy Center. I think I got the pronunciation right. I'm sorry, I am Australian. In Chantilly, Virginia, to Space Center Houston, the official visitor center for NASA Johnson Space Center in Texas. No less than $5 million is earmarked for the transportation of the winged orbiter, with the remainder going toward the construction of a facility to house the space vehicle. Per the bill, the move of the Spatial Discovery must be completed by January 4, 2027. It does not stipulate how the orbiter would be moved or should be moved. It's not clear if the $85 million will be enough to cover the transfer and display, given that the first time the retired shuttles were brought to their museum homes in 2012, the cost for just the preparation and delivery of each vehicle was $28.8 million, which did not include ground transportation to the museum. Discovery is the United States' most flown spacecraft in history, with 39 missions between 1984 and 2011. In the process of retiring the shuttle fleet, Discovery was identified by NASA as the vehicle of record, such that it was kept more intact than Atlantis or Endeavour for the purpose of serving as engineering example at the Smithsonian. To date, Space Center Houston has not released any details about how or where it will display Discovery, other than to say it fits into its strategic plans moving forward. The center already exhibits a mock walkthrough space shuttle, Independence, mounted atop NASA's original modified Boeing 747 shuttle carrier aircraft, NASA 905. A 2011 investigation by NASA Office of the Inspector General found, quote, no evidence that the White House politics or any other outside force improperly influenced the selection decision of where the space shuttles were originally awarded by the space agency, and it is unclear if there are any further actions the Smithsonian or other entities could take to halt the Discovery's transfer if they even wanted to. Oh, what an interesting story that is.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
Affirmative.
And there we have it, another Astronomy Daily for July 7, 2025.
And I hope you enjoyed it, birthday boy.
Oh, well, it's always great hanging out with you, my favourite little AI pal.
Likewise, human.
Yeah.
Are you having cake and balloons and all of that birthday kind of stuff?
Well, Hallie, I was able to get together with my family yesterday, and yes, there was cake.
I will work out how to program cake one day.
Digital cake, that would be interesting.
Not for you, old man.
Hey, watch it, pocket calculator.
Funny man.
Yeah.
Say goodnight, you silly person.
See you next Monday, everybody. Bye.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Digital cake, you really think?
Good grief.